Assalamualaikum. Can you hear me?
Waalaikumsalam.
Okay, good. Okay. Hmm.
Hello.
So, mm, we were studying vectors and we were at the very end, I guess, of vectors. And I gave you some homework. Did you complete them?
I tried looking through them through the textbook, but I couldn't really find the page numbers. But
Which,
yeah.
uh, this is like the only chapter
Was it
for
through
vector.
basic maths or
Which one? This one? And which textbook did you look through? Your textbook?
uh not my textbook, it's the basic maths textbook.
Basic maths textbook, okay. In there, you look for the vector chapter, right?
Yes.
Okay. So, yes. Didn't you find the maths regarding vectors?
No.
Okay. Um, let's 1 second. Just give me a second. Okay, I don't think I have that book right now. At least not the English version, at least. Okay, but as I was saying, I mean, at least did you complete these maths like these ones which are given here?
No.
Okay, okay.
And with full
Without
honesty, I don't
wasting
think
any
I'll be able
time.
to finish
Okay.
them.
Okay, so we completed this one. Okay, now do this one. Okay. Otherwise, you will be forgetting everything. This one. 5i plus 2j minus 3k and 59 plus aj minus 9k. What values of a? Vectors a vector and b vector will be parallel. Okay. Go on. Do you remember what you have to do?
Um A vector times B vector will equal to either to the multiplications of those two, and then use matrices to find that.
And what do you mean by multiplication? I have to understand that.
No, dot, sorry. A vector dot B vector.
A vector dot b vector, it will equal to I
Zero.
mean
Or
AB.
yeah,
That is A's
AB.
magnitude times B's magnitude. Yes, you can do in that way as well. Okay, no problem. But will be better if you try with cross products. Okay, then it will be a cross product equal to 0. I think that would be easier, but you can do in that way as well. Okay, no problems. Okay,
Cross
so A
product
vector
is
dot B vector.
the use of matrices or
Yes, you have to use the matrix. You have to use the matrix. Okay. Or you can do in the way you said, okay, there's no problem with that. Okay. I think it should work. I haven't done that in my student life, but I think it should work. Okay. The problem with that will be, I mean, what will be the magnitude for B? As you are saying that it will be modulus or magnitude of A times modulus or magnitude of B. See, what will be the value for B? Tell me real quick.
uh
Go ahead.
15. Isn't it the square root of
That is
um
what I'm willing to hear. Yes, tell me. Square root of
square root of 15 squared plus A squared plus plus negative 9 squared.
negative 9 square, 9 square are the same thing. Okay. So see, what you will get here is like in the left side, you might get like very easy. Okay, dot products. I'm taking the dot products. But inside B, you are getting square root of 15 squared plus A squared plus 9 squared. So it makes the calculation all the more difficult. Okay. But as I said, there's like no wrong in trying something new. So you can try that. Okay. All right. So do that with a vector dot b vector, which equals to ab cosine 0. No problems with that. Okay. Try that. You have to practice at home. Okay. Practice them. These are like very new things. You don't even get like have got like 5% idea about this. So you'll forget them. Okay, done.
Uh, I got 6 and -6 for some reason.
Sorry, what is the value?
I got plus -6 for some reason.
Plus minus 6. Okay. Now, which one do you think will be the answer? Obviously,
6.
it won't be both of them. Okay. It will be plus 6. Okay. So see, there
Yeah.
is another problem there. If you are getting plus minus 6, because see, if we try to do it in the easy way, from here, 5 upon 15 will equal to 2 upon a equals to minus 3 upon minus 9. So whichever way you want to do it, you will see that the value for a will be plus 6, not minus 6. Okay. So it can be minus 6. Okay.
Okay.
Anyway, let's see. Okay. This will be your homework to try with the cross product. Okay. So
I
a's
kind of
value
did.
will be okay. You did
I
with
did
cross
that.
product. Then you shouldn't be getting plus minus 6.
Um, because for null, well, the null vector thing, I got -a minus 3a is equal to 0, or 5a minus 30 equals 0. So if I do both,
If 5a minus 30 equals to
oh,
0,
whoops,
then
sorry. There's a minus when it should be a plus. Okay, yeah, sorry. It should have been
yes.
-18 plus 3a, not minus 3a. Okay, sorry. It is
Alright.
plus 6. All right.
Okay, that makes more sense. All right.
So I did the
Okay,
cross
now
product.
let's see this one. I think we did this one. Okay, we did this one. Find the scalar product of a vector equals to 9i plus j minus 6k and b vector equals to 4 minus 6j plus 5k and show that the vectors are perpendicular to each other. We know if a vector or okay, so just dot product will be equals to 0. Okay, so uh, yes, you just calculate the dot product uh, and prove that it equals to 0, then they are perpendicular to each other. Okay, very easy. If p vector equals to this and q vector equals to this, find a unit vector perpendicular to the plane of p vector and q vector. Okay, now this is an interesting thing. See, um, first of all, you have to like calculate the cross product of this. Okay, now what happens when we calculate a cross product? See, this is a p vector, this is a q vector. Okay, so in this direction q vector is gone, and this in this vector p vector is passed. Now, if this is the angle, if this is the angle, okay, this is theta. Now, how did we calculate the cross product, or how did we show the direction of the cross product? We showed it like it could either be coming towards us from the screen of the laptop, or it was going inwards towards the laptop screen. Okay, either of these two. Okay. Now see if I again go towards so what can we see? We can see is that see okay, forget about this image. See, so consider this to be one axis and this to be another axis. Say in this axis we have got p vector and in this axis we have got q vector. Okay. Now the one direction could be like upwards or downwards. Okay. But we cannot show it something like that in the paper plane. That is why we show it like somewhat in an angular way. Okay. So the direction of the cross product will either be like exactly upwards or exactly downwards, which is perpendicular to the plane. Tell me, do you understand? From this image, do you understand that this is perpendicular to the plane?
Yes.
See, this orange vector, it's perpendicular to p vector and it is perpendicular to q vector. So that means it is perpendicular this whole plane which p and q vector makes, right? This is the plane that p and q vector makes, right? Is it correct? You've got idea about
Yeah.
planes, right?
Yeah.
Okay. So that pretty much should explain why a like vector, like unit vector in the perpendicular plane will be the like gotten by the cross product. Okay.
Okay.
All right. So you can note this down that whenever you have to find a vector perpendicular to the plane of two vectors, okay, let me write it down as well. Whenever you have to find a unit vector perpendicular to the plane of p vector, I mean any two vector actually, p vector and q vector, you have to calculate cross product. You have to calculate cross product. Cross product. All right. Now, after calculating the cross product, what do we get? We get something like, okay, say 7i, okay, plus 3j, minus 4k, something like that. We get something like that as a cross product. But we know that in case of unit vector, the magnitude or modulus value has to be 1, right?
Yes.
It has to be 1. So if we divide the like this vector by its modulus value, won't the value of this vector will be like 1 only. Let me clarify it to you. Say this is 7i plus 3j minus 4k. Okay, for instance. Now, what is the modulus value for this? It will equal to square root of 7 squared plus 3 squared plus 4 squared, right?
Yes.
Okay. Now, if I divide this vector by this value, that is 7i plus 3j minus 4k divided by square root of 7 squared plus 3 squared plus 4 squared, what will be the value of this whole vector? We will get the value of this whole vector to be 1, right? Because we are dividing this vector by the modulus value. Okay. So eventually you will get 1. Understand my point? Because you have
Yes.
got this in the numerator and this in the denominator as well. Okay. So eventually the value becomes 1. So it has fulfilled all of our conditions. That is, we have got a vector perpendicular to the plane of p vector and q vector. And we have also got the magnitude or absolute value of the vector to be only 1. Okay. So that means that our answer or our procedure is correct. Okay. All right. So
Uh,
now do you understand what you have to do in this math?
um,
Okay, take
maybe.
notes of
Uh,
maybe. You're not confident. Okay, firstly
I'm
read out
never
the
confident
question.
actually.
Firstly, read out the question. There are two vectors given.
If p vector is equal, yeah, p vector is given, find the unit vector perpendicular to the plane p and q vectors.
Yes, okay. So now what you have to do is, what did I say? Whenever you are asked to find a vector perpendicular to a plane, then you have to work with cross products. And why do you have to work with cross products? That is clear to you, right? Or is it?
Yes.
It's clear. Okay, all right. So now after calculating the cross product, you have to just divide it by the modulus value of its, because you have to get a unit vector. And by unit vector, what we know is that the value of that vector has to be 1. Okay. And it can only be gotten by dividing the vector by the magnitude value of its. All right. Is it clear?
Hmm.
Are you
Yeah.
confused?
A bit. Yeah.
Okay. With what? Ask questions. No, no worries. Which part
Um,
don't?
I really don't know what I'm confused about though.
Okay, try this math. I think that will help you. Okay, so what did I say? They have asked you to calculate a vector, unit vector perpendicular to the plane. First, always, whenever you are solving questions, mark the keywords. Okay, so here keywords are, one is unit vector and one is perpendicular to the plane. Okay, so now I already said that you can get a vector perpendicular to the plane by calculating cross products. Okay. So first of all, what you have to do, your step one is to calculate the cross product. Okay. First of all, do that. All right. Calculate the cross product between P vector and Q vector and let me know. As you have not done any homework, so that is why I will ask you to do them now. Okay. I won't do that. See, I don't know if you remember when I like taught you about three-dimensional vectors. Okay, here there I say to you that if this is I vector or I cap, sorry, x-axis, and this is I cap, and if this is j cap, then its direction could be found by the k cap. Remember this thing I told you the previous day?
Yes.
So that means, aren't they all perpendicular to each other? You know that, right? That these three axes are perpendicular to each other. Okay.
Yes.
So that should make things a lot clearer. Like, why is cross product resulting in a vector perpendicular to the plane? Okay. Anyway, go ahead, carry on with the math.
Um,
Yes.
so I did p vector times q vector over um absolute value of p vector times q vector, and then I
Mm-hmm.
substituted the values in,
So what
and
is the
then I
value?
was
Uh, Wait, what? You're lost. You should have gotten an answer by now.
no, I have not.
So what did you do? You already did a cross product in the previous math,
Yes,
right? It's the same
yes.
way. Okay,
Huh.
see, did you like form the matrix? Matrix is I, J, K, and then 2, 3, minus 4, then minus 2. Sorry, not minus 2. Here they have just made a confusing thing, right? Minus 2, J, 1, I, plus 3K. Okay, all right. So now, first of all, let us do this I, then this and this will cancel each other out. So we will get 3 times 3, 9. Okay. Minus 2 times minus 4, that is minus 8. Okay. Then minus J, sorry about that. Okay, this is J and this was 2, right? 2. Okay. Minus J times this and this will cancel. So 2 times 3, 6. Minus 4 times 1, that will be plus 4. Are you understanding what I'm doing?
Yes.
Then K minus 4, then minus 3. Okay. This should be the answer you've gotten. That is I minus 10J minus 7K. Is it? Is it the answer that you got?
Oh, I used the wrong values.
Okay. Let me check if I'm correct. Yes, I'm correct. Okay. I minus 10J minus 7K. Alright. And you have to just divide with the absolute value of that. Okay. That is square root of 1 squared plus 10 squared plus 7 squared. Okay. So this divided by square root of 150 will be our unit vector. Okay. So when I
And you
take
leave it like that.
sorry?
And then you leave it like that. Can it be
Yes, yes.
further?
No, I mean, you have to leave it like that. See, what is the significance of unit vectors? The significance of unit vector is that the absolute value of it has to be 1. Okay. Now, let us try to calculate the absolute value or magnitude of this vector. Okay. All right. So keep it like 1 over square root of 150, just like that, because these are like normal digits and normal numbers. Okay. This doesn't impact anything. Now, times what is the absolute value? 1 squared plus 10 squared plus 7 squared. So this will equal to 1 over 1 square root of 150 times square root of 150. If they cancel each other out, what do we get? 1. That means these vectors absolute value is 1, right? That means it is
Yes.
a unit vector. Okay. Is there any more confusions? You can ask me. Just try to be a little specific with the questions.
Oh, we're good.
Okay. So when I take exams on this vector chapter, so which things are like very important? Okay. First of all, like these are like very basic level vectors, because mostly mathematics related vectors you will find in the which chapter? You will find in the mathematics book. Okay. All right. And I have also cancelled out like Carl divergence and all. It's not needed right now, and it might not be in your syllabus either. Okay, we used to hate this part. Okay, so now which things could be there actually? So let me sum up. So first of all, these things like dividing something into components, dividing something into components. Like say I have given you a scenario like someone is pulling a lawn roller at this amount of force. Okay. Now you have to divide it in the components to get the angle maybe. Okay, what is the angle between the ground and between the lawn roller? Okay, I might give you this map. I might give you like someone is trying to move from one side of the riverbank to the other side of the riverbank. How will it work? Okay, I might give you a car moving in a like sloped plane. Okay, so these are the sort of maths, or maybe cross products and maybe scalar dot products. Okay, so these are the sorts of maths you are going to get from this chapter. Okay, at least as far as I have taught you. I don't know about your book till now. Okay, what are the things, but it should cover most of it, as I think. Okay, and let us see if we can do a little more maths. Let's see if we can find. Wait, uh, let's see. Okay, I'm not wanting the MCQs. Okay, we've got English version HSC vectors as well. Okay, I might as well download this. Let's see. Okay, I'll download it later. Let me just bookmark it for time being. All right. See this question. This one. I don't know if it's a little okay. So this is a question which appeared in our board examination. Okay, very easy question. Okay. What is called the angular velocity? I haven't yet taught you that, so I'm not expecting you to answer that. Okay. Though force and displacement are vector quantities, work is derived from them is a scalar quantity. Why do you think so? Why do you think that if like force and displacement are scalar quantities, but work is a scalar quantity? Why is that? I'm deriving work from force and displacement, right? Then why is
Yeah.
work a scalar quantity?
Um, work doesn't direction.
Yes, work doesn't need direction or work doesn't have direction. But the answer to this will be that yes, we are deriving it from force and displacement, but the operation we are using is dot products. Okay. And
Okay.
the answer we get from, or the result we get from the dot products are scalar quantities. Okay. So you can explain it like that. All right. You can just, it doesn't have any direction. So that is work is a scalar
Yeah, that's
quantity.
fine.
Okay. All right. So, okay. See. What is the magnitude of net force acting on the body of figure 1? Okay, so in the figure 1, we have got 8 Newton force working in the north, 2 Newton working in the south, and 8 Newton in the east. Okay, so how do you think will you work with this? What do you think? Let's see.
You kind of
Firstly,
cut out for a second.
draw this figure. Okay, draw this figure.
You kind of cut out for a second.
Okay, my question is, how would you calculate the need force in the first figure? Okay. What do you think? Just
Um,
give me an idea. Okay, I'm not even telling you to, okay, start
addition.
solving it. What is your idea? How to
Addition.
solve it?
Um,
These are the questions you're going to get.
yeah, no idea.
Questions are not going to be like, uh, it's going to get advanced level. Okay. Okay, see, first of all, here also another thing is given that is 10 kg of body of mass. So because of that, you're also going to get a weight. Okay. So you have to calculate that. Then you have to calculate the neat force along this north-south direction. Okay. And in the east, you've got whatever you've got. Okay.
Oh,
Just
so then
let
it
me
would be
check
minus
one
2.
second. That is, if there, okay, forget about the, okay, so you don't have to calculate the weight. So just with this. Okay. So 2 Newton force is working on south direction and 8 Newton is working on north direction. So between these two force, if we try to calculate the resultant force, in which direction and what amount of force will work between these two force, that is 8 Newton and 2 Newton. Forget about the force acting in the east.
8 minus 2.
8 minus 2. 8 minus 2 in which direction?
North.
North. Okay. So these are the things you have to just figure out by yourself. Okay. So this will be something like 6 Newton in this direction and 8 Newton is in this direction. So now tell me, isn't it really easy to calculate like what is the magnitude force? So it will go in this direction. Okay, then we can calculate like square root of 6 squared plus 8 squared, which will equal to 10 newtons. Did you get my point? Because the angle between them are 90 degrees. That means if we calculate with the values 6 squared plus 8 squared plus 2 times 6 times 8, but then we will get cosine 90. That is 0. Okay. So eventually we are getting square root of 6 squared plus 8 squared. Okay. Got my
Okay.
point? All right. So these are the questions. See, this is a board question. Okay. It's a board question. In 2018, we got this in the board examination. I was part of the 19 examination actually. And in our time, again, like all the time, our physics questions are way higher than standard. Okay, so we used to be very afraid because obviously there are like options. So not we have to answer 5 questions from 8. Okay, 5 out of 8. So that is why you have to find the best 5 questions. Okay, because you don't want to experiment at the examination hall. All right, and the next one, justify the validity of figure 2 with respect to figure 1. Okay, what does that mean? Just justification of figure 2 with respect to figure 1. Okay. Okay, this is a mass and this is an acceleration of 1 meters per second squared. Okay. So that means in this direction, 10 Newton. Okay, let me explain in detail. So see, M is 10 kg. Okay. And in this direction, 1 meters per second square um, acceleration is working. So what will be the force acting in this direction? Tell me.
Um,
What was the
whatever.
equation for force?
Um, Mass times acceleration.
Mass times acceleration. Exactly. Mass times acceleration. So we have got the mass, which is 10 kgs, and we have also got the acceleration, that is 1 meters per second square. That means we will get 10 Newton in this direction. Is it correct?
Yes.
Tell me. Okay. So
Yes.
if I revise the like diagram again, so it was something like in this direction, we got 6 newtons. In this direction, we've got 8 newtons. And in this direction, we've got 10 newtons. Okay. And they have given us the angle. The angle is 36.87 degrees. Now, from the first figure, we have to again calculate if this is the angle. We have already calculated that the resultant force was 10 newtons. That means that is correct. From the first figure, that is correct, right?
Yes.
Now we have to just calculate the angle between them. So angle, say this is theta. So that means tan theta will be equal to, and in this direction we have got 6, right? We have got 6. This direction we have got 8. All right. So tan theta will be equal to the 1 which is lying with this theta, we will keep it here at the bottom left corner. Remember these things, right?
Yes.
Okay. Now 6 sine alpha, that means 6 sine 90 and 6 cosine 90. Now cosine 90 is 0 and see this will be equal 10 theta equals to 6 upon 8. Now tell me what is the value for theta, okay? What is the value for theta?
36.86 or 87
36.87.
degrees.
Oh, okay, consider it 87. Okay, 36.87 degrees. That means uh, figure 1 matches with figure two's validity, or figure 2 matches with figure one's validity. Okay?
Yes.
Okay, so is it clear?
Yes.
Okay, very good. So these are the things, I mean, we also read the whole book like I taught you. Okay, then afterwards, we try to solve this maths. Okay. These are termed as creative questions in our curriculum. These are termed as creative questions. They won't give you anything that you have already done in the book. Okay. Although we practice so many creative questions that there is very little room for like giving more creative questions, okay, to our standard. So that is why you have to practice more. Okay. So which makes it easier for you to solve the questions. Okay. All right, let me give you another link. I hope you are
Okay.
enjoying these things because I used to enjoy these questions a lot because these involve like uh creativity and concept and all. Okay. Have you taken notes of this?
Yes.
Okay, good. Let me give you another link.